Welcome back once again, guys. Hope you're ready. We're going to push together. And remember, mathematics is about consistency. It's not about waking up today and doing 2 problems and tomorrow you're not doing anything. It's about consistent hard work throughout. It's better to do 30 minutes a day than doing 5 hours on Saturday. What matters the most is consistency. That's how you're going to do it. If you have that fundamental, nothing will be impossible if you go ahead with consistency. Now, let's get to the business of looking at the measure of central tendency, statistics, okay? So, what are we going to look at now? We're still going to look at quartiles. We looked at mean already, which is the average. We're going to look at median. We're going to look at mode. Now we're going to look at the estimated mean. What does estimate mean? You know, it's the estimated mean, it's not the actual mean, but close to the actual answer. That's the estimated mean. Okay. And why we use estimated mean? Because sometimes we don't have the actual raw data. We can have data in grouped. We can actually estimate a mean for that grouped data. Let's look what this estimated mean look like to us, okay, and how we interpret that. So, estimated mean of grouped data. An estimated mean can be obtained by assuming that each of the raw data value takes the midpoint value of the interval in which it has been placed. The midpoint means halfway. Are we together? Midpoints means halfway. Interval could be how many, let's look at, I'll go back to COVID, the pandemic. The interval, we can, let's say people aged between 80 and 90, that's an interval. The midpoint between 80 and 90 is 80 plus 90 divided by 2, which is halfway, which is actually 85. Okay, so we're going to look at interval and midpoint. Because we might not have the actual data. We might have a table with intervals and frequencies. And how do we calculate the mean? So to do the mean, we'll do the sum of all frequencies times the midpoint. I'll explain, it'll actually make more sense if we do the actual problem. So this is the frequency, okay, times the midpoint. This is the total number of frequency, okay? Then mathematics, this is in words. That's the meaning of that, the mean. So this means, this is sigma, it just means sum of frequency. This x is the midpoint of an interval, and this is the frequency. And that means sigma means total. Okay. Let's see with an actual table how we can do this. During a 3-hour at an airport, 55 aircraft arrived late. So we know that 55 aircraft arrived late. That's what we know. So the total frequency for this will be 55. Because we're working with what? 55 planes that arrived late. The number of minutes they were taken is shown in the grouped frequency table below. So what we know is that planes that arrived late by 0 to 10 minutes, there were 27 of them. So 27 aircraft arrived by 0 to 10 minutes late. 10 by between 10 and 20 minutes late. And 7 by 10 to 20 minutes late. 5 by 30 to 40 minutes. 4 by 50 to 40 minutes late. And 2 by 50 to 60 minutes late. I mean, 50 to 60 minutes implies you're going to wait for an hour. That's too late, actually. I mean, even 40 to 50 minutes late is just too much for an aircraft. Okay. Now, we don't have raw data. We don't know plane 1 by how many minutes it was late, another plane by how many minutes late. We just have a table. How do we calculate the mean? So this is not going to be the actual mean. It's going to be the estimated mean. Okay. The average of being late. Okay, good. So we calculate the midpoint. How do we calculate the midpoint? The midpoint for this will be 0 plus 10 divided by 2. That will give us 5. This is the midpoint there. Okay, can you see guys there? Which is 5. Then the midpoint for there will be 5 plus 10 divided by 2. Okay, which is, we get 15. That's the midpoint. And the midpoint for 30 and 20 is 20 plus 30, which is 50 divided by 2. We get 25. And what about 30 plus 40 divided by 2? We get 35. And 40 plus 50 divided by 2, we get 45. And 50 plus 60 divided by 2, we get 55. What does this mean? Okay, this is the average, okay? Because remember, we have 27 flights, which is the frequency, that arrived by 0 to 10 minutes late. So what it means, there is a flight, an aircraft, which is late by 1 minute, maybe by 2 minutes, by 3 minutes. But this means 27. They're just between 0 and 10 minutes. Okay, now the average in that interval is 5 minutes. What does it mean? If an aircraft falls in that interval, the average of that flight being late is about 5 minutes. Okay, which is not bad to wait for 5 minutes. Okay, so let's look at the last one, which is between 50 and 55. 50 and 60. 50 and 60. There could be an aircraft which is late by 51 minutes, by 52 minutes, by 55 minutes. The average is 55 minutes is in that interval. I mean, you have to wait in that interval. I mean, it's 55 minutes. The max can be an hour, but the average is 55 minutes. Then from there, we have our midpoint. Now, we have to do midpoint multiplied by frequency. So what do we do? 5 times 2. 27 times 5. So 27 times 5, we get 135. That's the midpoint times frequency. 10 times 15, we get 150. 7 times 25, which we get 175. Then 5 times 35, 5 times 35, we get 175. And 4 times 45, 4 times 45, we get 180. And 5 times 2 is 110. Now we have midpoint multiplied by frequency. What are we going to do now is to add the sum of midpoint multiplied by frequency divided by the total frequency. And we know that the total frequency is 55 because 55 aircraft arrived late. Okay, so let's see what we get. So if we add all this, you can check that using a calculator. This is what I get. I get 925. Are we together? Divided by 55, which is the total frequency, okay, which is 16.8 minutes. 16.8 minutes. What does it mean? On average, if an aircraft is late, you have to wait for about 16 minutes and 8 seconds. Okay, does that make sense? That's what, does it mean you'll wait that? It could be longer, could be shorter. Make sense? Which is possible. Okay. So this mean, mathematical, if I have to do it, I mean, another symbol for mean is x bar. It will be sigma. Remember, this is the sum of m p times f, which is what we added, the sum of that, over the sum of frequency. This means sum. That also means sum. We call that sigma. It's a sigma. Okay. Good. Hope this makes sense, guys. Okay. Not the actual mean, but an estimated mean. Okay. Now, we've looked at the estimated mean. We still look at quartiles. We looked at the actual mean. We looked at the estimated mean. And think about what is different between the two. Which one will you take, the estimated mean or the actual mean of raw data? We'll look at the median. We'll look at the mode. Now we're going to focus on the mode. What do you think is the mode? Any idea? Have you heard of the term mode? The mode is the most occurring. Okay. What is the mode cell phone? The one you use at school, at your home. Think about it. Look at around. Okay? You'll find there is a mode. The most occurring one. Everyone that uses it. Okay. So, the mode in the data value that occurs most frequent. If two numbers that tie the frequent occurs, then the data set has two mode is called bimodal. So if you have two sets of data, I have 5, 5, 1, 3. 5 is the mode because 5 is most occurring because I have 5, 5 and 1, 2. 5 and 5 occurring the most. 5 is the mode. But what if I have 2, 2, 3, 3, 1? 2 and 3 that tie. So I have two mode. We'll call that bimodal. It's having two mode. Okay, great. Can you think of two things that tie together? Okay, it's possible. Then you can have the two mode. Okay. So let's look at this set of data. We have 48, 49, and so on. So, what is the mode here? So I have 50 there. Can you see 50? Okay. The mode is 50. 50 occur more often than any other number. So 50 is the mode. We together because it occur often more than any other. Okay. Fantastic. But what is interesting, let's go back to our, what if I don't have raw data like this? This is raw data because the data is not grouped. I can see the actual 48, 49, 52, 50, 51, and so on. I can tell that 50 is occurring more often than the other, hence is the mode. What about the table with the aircraft? I don't know. How do I tell the mode? If you go back, look at this. I want you to look at this. Now, here. Can we tell what is the mode here? What we know is that between 0 and 10 minutes, 27 aircraft were late. We don't know that aircraft 1, what time the first aircraft arrived, the second one, all the way, all the 55 aircraft. We don't have the actual numbers for the 55 aircraft. What we have is the frequency. Are we together? So the frequency, if you look at 0 to 10, that's the highest. So this, we'll call it a modal class. So it will be called modal class. Okay. What I'd like you to do is to go back to the COVID-19 pandemic. Look at which age is more affected by the COVID-19. Which class, which is the age class with the most positive cases? Go think about it. And I want you to go back also look at which class actually we lost because of the COVID-19. I want you to take time. We do know that the elderly, so you might find that between the age of 70, 80, 90, you have lots of people we lost because that's probably the mode. We don't know. But I want you to go and look at that data if possible. Okay. So actually this modal class is not really bad because implies most flight, they are late by 0 to 10 minutes. Most occurring. You know, I can wait for 10 minutes. But if the mode was there, that a flight will be late by 60 minutes, no. I wouldn't invest in that business or that aircraft. So we can use data to really analyze what is happening. I mean, you can analyze each and every aircraft if they arrive on time. Do you really want to invest in that business? Do you really want to book that aircraft? Because every aircraft in that company might be late by 50 to 60 minutes. Not a good idea. Okay, guys, so we looked at the mode, and when we come back after break, we'll look at another measure of central tendency. Okay, here I was trying to show you when we have a table, how do we really get the mode? We don't get the actual mode, we get the modal class. Okay, fantastic. Hope to see you after the break.